Hello guys, this is Manak, your civil bro. So this is the day 10 of the course on STAAD.Pro, which we've started together, and hope you have practiced all the lessons which we have done earlier because there was a gap uh, in which you got sufficient time. So today we will move on to the next part of our lecture. Now we have designed and building according to all the loads, and we have designed the second building, that is one live project according to all the loads. And now we'll see how to assign the wind loads in the STAAD.Pro. So I will divide this lecture into two parts because there are some theory parts from the codal provisions which you need to know for the wind load. And after that, in the next lecture, in the next class, we will just apply the loads in the STAAD.Pro. So as we all know that the IS code for the wind load is IS 875 part 3. Now, make sure while you download the IS code, you make sure you get the latest version of the code, right? So the latest version of the code is, IS 875 Part 3 2015. In YouTube also, you'll get many videos that there are some code provision explanation, but make sure, but they are old ones. Okay, latest ones you might not find till now. So make sure download the IS 875 Part 3 2015 because it's the latest version, and you should always follow the latest version of IS code which is available, right? So moving on, we will just start the explanation. So the first part of the lecture is the your zones. So like the earthquake zone, we also have some wind zones. So wind zones we are having, as you can see in this page 3 of this particular map, we are having actually 6 wind zones. So you can see right now I am here. So this is wind zone 6. So northeast part is actually very dangerous in terms of building construction. Not dangerous in that sense, because you have here seismic zone 5 and also wind zone this 6 of the maximum wind speed, basic wind speed. So basic, according to basic wind speed, we have the 6 schemes, color schemes, as you can see here. If you are in UP, like Allahabad, and almost the entire UP except some parts, this one is in this green zone, which is a 47 meter per second basic wind speed. Northeast, this in northeast you find Tripura, Mizoram, and in some parts of this Assam, here in 55, and the remaining parts in 50, and the remaining parts in your 44. So the blue one is 44 and the yellow one is 39 and 33. You can see these are the basic wind speeds for all the area here. You can see Kolkata and Bhubaneswar. Also you can see basic wind speed of 50. So this is the map, and you can find in Annexus C also there is there are cities mentioned. Otherwise, you can find the city, and you can find the basic wind speed formed here. So now the most important equation which we need to see in the wind load, which I'll show you right now. So the most important equation is the design wind speed. So in page number 8 of the PDF, okay, page number 8 of the PDF, if PDF consists of 69 pages. So we just tap 8, you can find this page. And by the way, this is page 5, but in the PDF, this PDF, whether using Adobe PDF or Foxit PDF, just type 8 and you will open this page. So basic design wind speed is clause number 6.3. And what is it? I'll just tell you. Design wind speed VZ or VZ equals to VB into K1, K2, K3, K4. So in the latest code, they have added a new factor K4, right? So what to do now? VB is the, this, this thing which we had seen here. VZ is the design wind speed, okay? K1, K2, K3, and K4 are the factors. VB is the basic wind speed. So basic wind speed we can find from the map, okay? The basic wind speed VB we can find from the map, which I had shown you right now. If you just mention the city, suppose in Agartala, Tripura, the basic wind speed is 55 meter per second. You get the basic wind speed. Now then you have to multiply by some factors K1, K2, K3, and K4. So now if all these factors equal to 1, then basic wind speed equal to your design wind speed. There is no doubt in that. But now we have to see how to find out this K1, K2, K3, and K4. So it's very easy in the code it is given. So we'll move to page 10 of 69. Just press 10 and enter. And then we'll find here this is the K1, that is the risk coefficient. So if I just zoom in to show you a better view, the risk coefficient for all general building is your for a design wind speed of 55 meter per second is 1, as you can see here. So based on, suppose we are going for Agartala Tripura, basic wind speed is 55, and if we are constructing a general building, then it is 1. If it is a temporary shed, then it is a 0.67, and important buildings such as hospital, then it is 1.08. So it depends on two things, the type of building and also the basic wind speed of the area in which you are constructing the building. So this is the case, and for this next category as well, that is the K2 factor as well. We have to decide the terrain category. Terrain, we know the land patterns or land condition which we live in. So we have actually four categories of terrain, and basically if you just give a reading of this terrain categories. Terrain category one is exposed open terrain. So if you are constructing building in an open area like open park and underdeveloped area, then it will go in category one. And then in category two is the next category. You can find this is the category one average, and then you will find here the category two, and category two is the next criteria. And this example, just example you can see here. Example is open land adjacent to sea coast, and this open parks and underdeveloped areas. So total open area category one, and open area adjacent to sea coast or open parks underdeveloped areas, this is category two. And category three, if you are making a building in a city where you have a lot of buildings nearby, and this will come in category C. Okay. And then in these are the three categories actually. And in category four, and category four is for this multi this tier one cities where you have large multi-story buildings nearby, so that will come in category four. So these are the categories. So generally you can choose most of the buildings is between category three and category four. So these are the categories which you find. Okay. And now for for determining the K2 coefficient, first of all, or K2 is also called the this terrain factor. So risk coefficient and then terrain factor. So terrain factor, if you want to find, just you can go to page 11. Okay. And in page 11, you will find here this table, in this table number 2. So in table number 2, you will find this, suppose in I want to make a land in a populated area. So it will come in category 3, and the height of my building is it's generally 2 to 3 story building, 10-meter height, let's suppose, category 3, and the K2 multiplier will be your 0.91. So if I make a go up to 20, then it will be 1.01. So like this, this K2 factor is determined according to different categories, right? So you can observe that when you have an open area, then this value increases, because open area there will be more exposure to wind. Terrain category one is obviously more exposure to wind. So in open area, I can select the terrain category one and see the value of our terrain factor coefficient is your larger. Okay. So this gives a K2 factor. So now we're going to come to K3 factor. So K3 is the topography factor, topography or K3 factor. So now in with this we have a clause. You can find this K3 factor in clause number 6.3.3.1, still page 11 of the PDF, and it has in written here in the code that if the upwind slope or theta is more than 3 degree, and then we have to consider the value of K. Okay, K3. So we can there are processes to calculate the value of K3. But if the upward wind slope is less than 3 degrees, then you can take the value equal to 1. So what is written further? The value of K3 is confined in the range of 1 to 1.36 for slopes more than 3 degree. So if we had to go on the conservative sides, suppose wind slope is more than 3 degree, you can take 1.36. Okay. So that will cover everything. That will be on a little bit on the conservative side, but that will cover everything. You can take 1.36, but if it is the wind upwind slope, if you just confirm, if you have a confirmation that the upwind slope is less than 3 degrees, then you can take 1. So 1 to 1.36, and in details is given in Annex C. We'll not discuss about that right now, but this is the range here. Okay. Okay. So K4. Now K4 is the thing which has been recently added in this code. So I'll just read it out entire thing. The east coast of India is relatively more vulnerable for occurrence of cyclones. So you have seen cyclones in the eastern coast of India, along Odisha, along your West Bengal. You can see most of the cyclones occur there. On the west coast, Gujarat is vulnerable for several cyclones. In Gujarat, also cyclones come. Studies of wind and damage to buildings and structures point out to the fact that speeds in the basic wind speed of the map are often exceeded during the cyclones. So what happens if you see the recent cyclone in Odisha also, that funny, almost the electricity was, gone for 1 month in most parts of the state. So you can see the basic wind speed are not enough. So that's why this factor has been added. The effect of cyclonic storms is largely felt in a belt of approximately 60 kilometer at width of the coast. In order to ensure safety, this region, K4 is recommended, and the structures of post-cyclone importance emergency services, it is taken as 1.3. So structures which are important for, when a cyclone occurs, it is important for rescue and important for rehabilitation. They are that, in that structures you can take a K4 factor of 1.3. And industrial structures, like in all the industrial structures, in commercial or industrial structures, you can take a K4 factor of 1.15. And residential building still, you'll take 1, because if you take another additional factor in the residential building, it will really be much more less economical. So it will be very heavy structure. So that's why now other structure is 1. But if it's a school, hospital, then it's 1.3. Industrial buildings 1.15, so that any type of accident at least doesn't happen in industrial structures and cyclone important structures. And if required, then we can just repopulate the residential building people to those structures. That's why this K4 structure is given. K4 factor is given 1.3 and 1.15, but it's only for the places where you have, your uh, this cyclonic region like Bhubaneswar, West Bengal, parts of West Bengal. So those regions where cyclone occur frequently. So there you have to consider this K4 factor. Okay. So this is the thing which is the basics for calculating the design wind speed. And then you will have this another thing in terms of design wind pressure. So design wind pressure is actually, you can just read it out. Design wind pressure at any height is defined as this. So design wind pressure will be applied on the building. So we have to calculate the design wind pressure. So design wind pressure PZ is simply 0.6 into VZ square. So VZ or VZ we already have calculated. That is the design wind speed. So design wind speed square into 0.6 will give the design wind pressure. Sorry, wind pressure. And the design wind pressure will be PZ into some factors KD, KA, and KC. So KD and KA and KC, all factors you will see from here. You can find out from here KD. So KD for normal buildings you can take as 1, and for this towers, trusses, etc. you can take as 0.9. And KA it is given, suppose you have this tributary area. So suppose you have this facade area. Tributary area definition is given. It is you can just read it out. But generally it is the facade area. If you take KA as 0.1, there is no harm in that, because 0.9 is actually we are reducing it. So you can take KA as 1. Okay, if you are not sure about it, because otherwise you have to calculate the tributary area. So tributary area is this for revolting roads from the tributary area shall be taken as the center to center distance between the frames multiplied by the individual center panels. Center to center distance into this an individual panel dimension. It is generally the area or frame area in which the wind acts, or the facade area also you can say. But generally you can take it as 1. We don't need to have to read, because all the other factors are less than 1. So it will not harm. You can take the KA factor as 1. And then you can find the KC in page number 16, KC factor. So you'll find it here. Okay. So we're looking for here KC. Sorry, you will find KC number 19 or page number 16 of the PDF, 16 of the code and 19 of the PDF. So taking the combined effect of the frame and reduction factor of Kc equals to 0.9 may be applied. So almost all the factors will be 1 and the Kc will be 0.9. So like this, you can find out this also. So another important thing is your, the coefficient. So that you have to find out. So the force coefficient you will find in page number 35. So this you will find page number 35, force coefficient F equals to CF into AE into PD. So if we're confusing, so mainly the frontal area of the length into breadth of the building, length and the height of the building is AE, and this PD is the design wind pressure, which is 0.6 VD square, into VZ square into your this factors which you've seen almost into 0.9. It will be in most of the cases, okay, because other factors are 1. So it is CF into AE into PD. So PD we know because we had seen that design wind pressure. AE, we know how to calculate the length of the building, the whatever the maximum between the length and the width, you'll see that, and into the height of the building. And CF, how to find out, we'll find in page number 38 of the PDF. And this is in the code, it is page number 35, and the PDF page number 38. So we'll find here how to find out the value. If H by B, height of the building, then you can see height of the building by the smaller dimension of the building is less than is greater than 1, then it will follow this figure. And if it is less than 1, then it will follow this figure. So from here, you can find out by interpolation, or you can take out the values from the graph. There is software to actually convert the graph into Excel values. Also you can use that, or else you can just use an approximately you can get a value. You can see for different values, you can find H by V values, you can find out this. Okay. So this is how we find everything. But right now, I believe if you don't solve a live numerical or problem for this, you won't understand. That's why I have taken a separate class for this. Okay. You can also make this Excel sheet with pretty simple process. So here the length of the building is 10.6 meter. I've taken a building. Width of the building 25 meter. The height of the building also this 25 meter I have taken. Multi-story building. So now you can also change this. Suppose I take this as let this 25 meter only. Okay. And location I've taken Agartala, Tripura. So if I have shown you in the map, the Agartala, Tripura is in northeast portion, and the design wind speed here is 55 meter per second. So that I have found out from the map, and here I'll go to the K1 part. First of all, I'll just show you the map probably. Where is this Agartala, Tripura? You can see here. Here. So here is Agartala, and it's pink color. So it's 55 meter per second. So that's how we got this VB equals to 55 meter per second. Clause we have written here. You can just take the screenshot. And then K1. Now K1 is in page number 10 of the PDF. So we'll go to page number 10. And there you find the K1 for all general building and structure is 1. Okay. So I've taken K1 equals to 1. Then K2, and K2 is in page number 11 here. And just go to page number 11. K2 here. Let us take terrain category 2, and or building of height, or terrain category 2, the building. Let's take terrain category 3. So for terrain category 3, for building of height 25 meter, it will be between 1.01 and 1.06. So let's take roughly 1.03. Okay, 1.03. So K2 will take 1.03. Let's see, take here 1.03, and K3 here, K3 K3 will also be from page number 11. Let's consider upward wind slope less than 3 degrees. So K3 will be 1. So let's take K3 equals to 1, and K4. Agartala, in Agartala, I'm constructing a residential building, so I'll take K4 equals to 1. It is not that much of a cyclonic area, but sometimes occurs. But okay, I'm designing for residential building, so I'll take 1. So my VZ comes, this product of all these things. If you see product of all this VB into K1 into K2 into K3 into K4 as per clause 6.3, I said 75 equals 56.65. Now I'm going to need this ratio A by B, A by H, A by B, A by B again or 2 times. Okay, I can just delete it. Okay, HYB, CF, and all this I want. So CF, actually I found out like this one CF using the figure 4. So let's see how I have found out CF. For the CF I need these three things. Okay. So CF page number 38 of the PDF. So I'll go straight forward to page number 38. Now my A by B, first of all I have to follow this one. H by B is less than 1 or greater than 1. So let's see, my H by B is 2.335. So it is greater than 1. So definitely I'll follow this figure. Now for among one of these graphs, I need this your H by B value. So H by B value is 2 point something. So I'll take, let's take this graph 3. I can interpolate on all, but I'll take on approximate one. Let's take this 3 graph having 3 on it. Okay, because my value is around 2.35. So I'll take 3 this graph, and my A by B is around 2.35. So A by B is 2.35. So it's around here somewhere. I'll just show in the this. So it's around 2.35 is around here somewhere, and in this graph it is here. So the value is around, it is less than 1.25, 1.5 by 0.5 by 2, 1.25. So it is less than 1.25. So let's take 1.2. So 1.2, let's take 1.2, or let's take this 1.2. So CF is equal to 1.2, approximately like this. You can find out. For accurate, there is a software where you can plot and all, but approximately, almost approximately, you can just take it from this graph here. Okay. Now then the wind pressure, PZ equals to 0.6 BZ square. So that is very easy. You will find out this. And the design wind pressure KD into KA into KC. So KD and KA we already discussed just now. KD and KA in most cases will be 1, and KC also in most cases will be 0.9. So just put this value, we will get the design wind pressure. And after we get the design wind pressure, we already have the force coefficient CF, and we multiply using this formula. CF equals to A into CF into A into PD. A is actually the, I have taken this as the length of the building into the height of the building. Okay, so like this I have taken this AE. So AE I got, PD I have from here, CF I already found out using the graph this CF. So I find out the total force in kilonewton. I have divided by 1000. You can see in the formula I have found the total wind load F on the building. So this is the process actually to find out the total wind load on the building. So this is the 10th class, and right now we have seen some aspects of the wind load. To understand the codal provision, so every code is very important. That's why I had to make a separate lecture on this part. So make sure you go through the code here and develop your interest in the the topics, and so that it's not just STAAD.Pro. Whether you use any software, if you are just suitable with these terms, any updated software also if you use, you can easily apply the wind load or any kind of load if you understand the code. So understanding of the codes is very important. So keep practicing, and if you have any feedback, just let me know in the comment section. And watch the video till now, then drop a like. It helps out in the algorithm. Okay, then happy Sunday. Bye bye.